Greetings folks, welcome to a chat from the engineering desk. Hope you're all doing really well today. So the last time I took one of these lamps apart, we found this inside. This was one of the house brand lamps, and it was found to contain some good stuff. We were quite happy with what we found. So the other day in the store I was looking for some more lamps, and one of the problems was that they only had bayonet cap flavored lamps in stock. But I decided to purchase this anyway because it is an Osram 9 watts. So I don't intend to use this because I've only got Edison screws in my house. So I'm going to take it apart and see how this 27 Rand light bulb compares to the 25 Rand light bulb that I took apart previously. Now the first thing I'm noticing is that the front of it doesn't just snap off like I could with the other lamp. In fact, it's pretty well sealed. So I think we're going to have to pry our way into it. Try not to injure ourselves in the process here. Has that been cemented? Let's keep going and find out. It looks as though this has been glued shut with an adhesive. Interesting. Not to worry, we shall spudge away at it till it yields its contents. I can see some metal here as well. In fact, I can see the LEDs. So let's keep going and get this off. I'm going to pause for a while so you guys don't have to watch me doing it. Be back in a moment. Right, we're back, and I have opened this up far enough. And we pull it apart. So that had adhesive. Interesting, this is showing quite a strong similarity to the other unit that we took apart last time. I see that more attention has been paid to where the adhesive has been applied. It's actually celestic all the way around. Now, let's see what happens. We apply leverage. The board, it just got the chips on. Is it going to exit? There we go. Oh, interesting. A zoomer in. There we go. Got a nice carrier for the PC board over there. that has been nicely done. Down the bottom, it looks as though it's just got some sleeved wires connecting it to the base. No fusing or anything. And there's the fuse. There's a bridge rectifier. So DC goes through a resistor and an inductor, as well as a capacitor. Once again, this appears to be a non-isolated type of driver. So there's the capacitor for the smoothing. On the LED side, there's the inductor for the buck converter. Bear with me for a moment while I have a look at the the chip. Can't really see that. Nice big LED chips. Nice aluminium backplate. Okay, bear with me for a moment while I go and photograph these with a microscope and get the data sheets. See you in a moment. Hi folks, so I'm back, and the internet didn't yield much about this. There's the bridge, input bridge. We know that's just a 4 diode bridge. This over here, the internet yielded nothing about that port number, but we can assume that that is a standard non-isolated buck converter chip. If you examine the components associated with it, I don't think there's any secrets about what's going on here. Other components, there's the diode for the converter. That resistor, I'm not sure what that's connected to. I think it's actually across the inductor. The interesting stuff here, there's your 3.3 ohm current shunts. And then over here is how the chips have been mounted onto the backplate. Got a shot of that. And that's the long and the short of what's going on in here. And essentially when you compare this lot to one another, internally they're very similar. Have a closer look there. So very similar things going on here. Both of these are very similar. This one wasn't glued onto the base. There's its base. Also with a slot for the PC board, and then the aluminium housing over here, which serves as a heatsink for our little LEDs over here. Both of these lamps are rated at 7 watts. So this one over here, it's housing identical. Its base feels heavier, so I think there is a bit more meat in this heatsink over here. It's got the slots, the PC board carrier, and it is well and truly glued onto the diffuser. So there's actually not a lot between them. That explains the small price difference of, I think, $2 or $3. Both of them nicely made. They got the right type of stuff in them, conversion wise. What I still need to do is hook this up to a scope and see what sort of signals are being generated out of the chip and what the current waveform looks like, and if and what kind of stuff is getting back onto the mains from this. This one I notice has got this inductor here for some decoupling at the high frequency to keep that out of the mains, which this one didn't have, but it's got that RC snubber. So there we have it. Very nice. Thanks for watching. Keep it classy. I'll see you next time. Cheers.